Hey guys, today I'll be talking about the Travel with SwAG application by the SwAG team, also known as the Software Agents Doing Great Things. My name is Tom. I worked on this together with my teammates Tawakram, Hamza, and Sid. So, why do we focus on travel? Um, I think the main point is that we were told that AI is going to solve all kinds of travel problems. Spoiler, it hasn't so far. Um, I think we were told that AI is going to be able to book your hotel for you. It's going to be able to plan your trip in the optimal way. It's going to do it the cheapest. All this kinds of stuff. And I think that most AI travel applications, at least at the ones that are highly rated, are either ads or not that useful. So we wanted to build something that works on the ground to help you navigate a place with SwAG. And we also knew that we wanted to use multimodal models since this lets the model interact with the world in the same way that you do, kind of reducing that cognitive gap. So I think that's really important to um, take into account. So what is Travel with SwAG? Travel with SwAG is an agent-based multimodal tour guide that helps you navigate and learn about your current location. We have two main features, the SwAG Assistant and the Everywhere Tour Guide. Firstly, I'll talk about the SwAG Assistant. So this is solving the planning problem with AI. Um, we benefit from function calling to integrate tools for route optimization, geolocation, and web search. So this means that users get the best possible trip plan at the lowest cost directly within the app. And we have a demo for this. So the user is going to ask about a trip, and they're going to say, I want to plan a trip to Marseille, um, to eat tahine, to hike to Mont Blanc, and visit Barcelona. What's the total road trip distance and how far will I hike on foot? And they'll also ask the assistant to plan an itinerary for them. So the assistant is going to think for a while in order to come up with the best idea to correctly respond to the user query. Um, and to do so, it will start making calls to some of our tools. So it's first going to search the internet for coordinates, since it needs these for some of the other tools that it will use. For example, the get distance matrix tool, um, in which case it uses some of the coordinates of the locations mentioned. And it also suggests the mode driving, which means it's assumed that the user is driving around given that they are going to take a road trip, which makes sense. Once it's collected all the information that it needs, it's going to return to the user a full report on what they should do. So it's going to provide them with the distances between Marseille and Mont Blanc, and then Mont Blanc to Barcelona, and correctly sum those distances. So 450 plus 780 is 1,230, which is a correct summation. It's going to tell us about hiking along Mont Blanc, what that's like. It's going to give us a full itinerary of our complete set of travel, so starting in Marseille, going to Mont Blanc, and then to Barcelona. And it also mentioned where we can get tahine, so one of the Moroccan restaurants in Marseille. Um, and it's going to give us some advice as well. And then, of course, from there, the user can continue to ask about their trip. They can say, recommend me some Moroccan restaurants in Marseille, and it will be able to provide the answer to that. So, pretty interesting stuff. I think this is a really useful tool. Moving on to the second feature, which is our Everywhere Tour Guide. I like to call this feature a personal, patient, and smart tour guide from within the user's pocket. So, given a photo taken from the user's current location, it then analyzes it and uses tools to research what that is, what they're looking at essentially, and then providing the information back to the user. The spin on this is that it uses SAM, or the segment anything model, for precise object segmentation, which allows the user to ask about specific features within the image. Um, the user can ask about a range of things. For example, normal things like bars and restaurants and shops, which the model will respond with reviews or opening times or some maybe history about the building if it's a famous building. The more interesting um, things the user can ask about is monuments, landmarks, and artworks. And this is where the SAM feature really shines because they can ask about specific sections of landmarks or specific sections of artwork. Um, and we'll go into a bit more detail on this later in the video where we do a demo um, of this. Before that, I have a demo on the streets where I go around my local area um, and test it out and see how it performs.
Hey guys, today we're testing out the Travel with SwAG app on some locations in my local area. Let's go. This actually looks interesting. Let's see what it can tell us about it.
So here I am taking a photo of a statue on Chiswick High Road. That's all the model knows. It knows I'm in Chiswick and it knows that, well, it can see that this is a statue, right? We upload the photo to the model um, in order for it to give us information about it. We then click on the statue to tell the model we want to know about the statue, um, and then it's going to process that and give us a response. It sees the statue and it sees that the statue has the inscription Hogarth um, on it, and given that we're in Chiswick, it's going to make a search query to the internet um, trying to figure out what this is. Once it's collected all that information, it's going to give us a review of what it's found. So it's going to tell us about the statue itself. So it was unveiled in 2001. It's going to tell us a bit more about the actual statue. So who is it? It's a figure of Hogarth himself. And there's also a pug dog at his feet, which was a specific detail included separately by a pupil from the William Hogarth School. It's going to tell us why Chiswick, why this is in Chiswick. This is because Hogarth lived here for a period of his life. Um, who the statue was funded by, and then interestingly, it's also going to search to see if there is any kind of Hogarth-based museum nearby that we could maybe visit if we were interested in the statue. There isn't. This is actually further away from this specific statue, therefore it doesn't recommend that we go there. But if it was close, potentially it's going to recommend that we go and visit the Hogarth Museum.
Cool. We're at the Pack Horse in Talbot, and we're going to see what it says about it.
So here I am taking a photo of a pub called the Pack Horse in Talbot, and we're going to upload it to the system in the same way that we did before, and hopefully it will tell us some information about it. Again, it correctly recognizes this is a pub and that it's a Green King brewery, which I think is really cool. Before starting, in this case, it's actually going to confirm that we're nearby, just to make sure that the model kind of doesn't make any assumptions or hallucinate the responses. We want to confirm that we're actually nearby this pub, or at least we're actually nearby the pub that it thinks we're nearby. Once that's confirmed, we're going to search the internet for details about it, the same way that we did for the statue, and it's going to provide us with some information. It's going to provide us with the historical significance, telling us that the pub has been operating since the 17th century. Tell us the reviews, so 4.3 out of 5 stars, which is pretty high. Some of the features and facilities, along with the opening hours as well.
Sounds like a nice pub. Let's go in. Thanks to Travel with SwAG, I'm going to get a lovely Guinness. I'm on.
So yeah, that was the demo on the streets.
Hey guys, today
I also wanted to do a more in-depth example on SAM v2 because I don't think that the mobile application does it justice. So in this case, we're going to spoof our location to the Trevi Fountain and interact with the backend of our application directly. Now let's say, for example, I'm standing in front of the Trevi Fountain and I want to know about this specific statue. So I'll upload the photo to the system, tell it I'm going to click on this area in the photo, and that returns this, which is using SAM 2.1 Tiny, so a small model, to segment an object within the image based on the user's clicks. And it's pretty powerful considering it's the smallest available SAM model. Then what we'll do is we'll upload both of these images to the Anthropic API and essentially tell the model to do spot the difference and figure out what does the user want to know about specifically from this image. So we have a demo of this working. And in this case, as I mentioned, we're interacting with the backend directly rather than the front end because we wanted to spoof our location. So we can see that straight away this recognizes that this is the Trevi Fountain in Rome. But before starting, as mentioned, we're going to confirm it. And we can see that it's tried to query the search for nearby places with actually the incorrect place type. But due to our system, the model was able to kind of recorrect that and correctly query with the new type before continuing. Once that executes successfully, it's going to start to query the internet for some information about the Trevi Fountain. And once that returns, we will be able to see the response from the model. So we can see here that the model has correctly recognized that we want to learn about one of the statues in the right-hand side niche. And this is the statue of health, and the model has told us that, which I think is really cool, health or salubrity. The model also tells us a bit more about the Trevi Fountain as well, which is cool, but mainly focused on the specific statue that we clicked on. Before fully returning, it then reconfirms that we are actually at the Trevi Fountain, just to prevent any kind of incorrect assumptions or hallucinations. But yeah, I think this is interesting. So, moving on. I thought I'd talk a little bit about our tools that we have available for the model to use. Some of the more interesting ones were, which you've seen, the search and read internet tool. This uses Gina AI's search / read APIs to allow the model to query the internet and then get information back in a nicely formatted way that is easy for the model to interact with, so it's not a lot of HTML. Of course, we have the Google Maps API, so we had a range of tools for interacting with that in a structured way. So for example, searching maps with text or searching for places of a specific type nearby or getting directions between two places. And then we also had route optimization. So we had some tools based on that, including obtaining a distance matrix between a set of places, along with, of course, then route optimization between those locations. The full set of tools is available on GitHub, so if you're interested, I recommend checking that out. So we had two front ends. This front end is the one that you'll see on the GitHub application. So for our MVP, we implemented a simple one using React Chatbotify, and then we also implemented a series of predefined conversation paths, which makes it easier for the model to interact with what the user is saying. Due to technical limitations, we weren't able to implement kind of true streaming responses. So instead, we collected the complete response first and then performed the simulated stream so it all looks natural, which is why the demo in the streets video that you saw was slightly edited, just so we weren't looking at kind of a blank screen for 15 seconds or so. Some future work that I think would be really interesting. The main one I think is integrating this with AR and VR, specifically allowing users to interact with SAM via natural pointing gestures, kind of like what Anya is doing here on the right. I think being able to do that like without even taking the AR goggles off would be really interesting and very cool. Next up, I think we want text to speech, and speech to text. Of course, this allows the tour guide to communicate findings directly to the user without them having to look at their phone. And it also improves the inclusivity of the application, allowing people who are visually impaired to use it and get information about their surroundings. We also want to add memory, and I think it would be really interesting to have the system grow with the user, so understanding the types of the responses that they'd like to hear and the types of information they'd like to know about. Some technical limitations. The first one we ran into was API latency. So when you upload an image to Claude, it's quite significantly slow in order to process that whole image, um, along with the Gina AI endpoints are not as quick as we hoped they would be. So future implementation will leverage Gemini Flash rather than Sonnet and a custom web search infrastructure if we can get it faster than Gina AI's. Again, as I mentioned, we had no real-time response streaming, so we plan to improve that by implementing real-time token streaming, which I think provides better immediate user feedback. We also had constrained model interaction, and I think we'd like to switch that to be unconstrained. The way we would do this is by implementing maybe some advanced tool retrieval or query routing systems, which basically allow the user to interact with the model in any way possible, and then in the back end we will figure out where that needs to go. I have one more demo, which I think is really interesting, and this is the painting that Anya was pointing at a few slides ago. It's a painting by Dali in the Vatican museums, and specifically we're interested in this blob um, on the left-hand side of the painting. So again, we've spoofed our location, um, so we'll interact directly with the backend, and let's see how it performs. So it's going to make a request again. This one takes a little bit longer because the image provided is a bit larger. So again, you can see that latency from the Claude API coming in here. But we get a response, and the model correctly assumes that this is Dali. Now, for lesser known artists, this would be a mistake. So it would be recommended that the user provide the artist who actually made the painting or the artwork themselves. But for famous artists like this one, it's okay for the model to figure out itself. It's then going to search the internet to figure out what the painting is called based on the information that we are currently in the Vatican museums. It's going to go to dali.com to figure this out and then hopefully return a response. So we can see here that it provides some detailed information about the object in the blue area. We know that it's part of a painting called Soft Monster in an Angelic Landscape, which is correct, and currently housed in the Vatican museums, which is correct. And this first point here is the details on that soft monster figure, which is a variant of Dali's famous Great Masturbator motif that appears in several of his works, which is the correct is the truth, right? The model has got this correct. And then it gives some more information about the painting itself, along with the fact that these soft melting forms is a characteristic of Dali's surrealist style. So I think this is really interesting and a really unique way of interacting with models, but also very useful. I think that being able to find out information about specific parts of paintings, stuff which you potentially wouldn't have known just by walking around the museum, is something that really interests and excites me. Awesome. That is the whole presentation. I hope you enjoyed, and I hope that you're interested in the application and excited to try it out.